Good morning everyone. Hope you are doing well. I am Ketan, part of Actarre Build training network, and today we will learn about ethylene tetrafluoroethylene foils as a construction material system. Now this podcast is presented by the Actarre Build training network, and I hope you will learn something new today from it. A little introduction about myself. I am a doctoral candidate at Politecnico di Milano and University of Valladolid. So let's talk about ultra lightweight architecture at a glance. It is an opportunity for us to reduce the carbon footprint in the construction sector, which is currently polluting a lot. Let's just, if we read the numbers and imagine it is only one sector, so how much pollution this sector is bringing to the world is alarming, and that is why there is a need to move beyond the traditional techniques of building architecture and going towards lightweight architecture. Today we will be learning about ETFE foil cushion system. Now, what is ETFE foils? So, ETFE foils are more like plastics. If you imagine, they get of 100 micrometer to 350, 400, 500 micrometer is also possible. And how do you construct a system out of it? That there are predominantly two types: mechanically prestressed, so you use it as a single layer; pneumatically prestressed, so you combine this foils into 2 or 3 layers, push air into it, and make a cushion out of it. Now, uh, this is how you made a system out of it, and where it is used, you may ask. So, it is predominantly used as a cladding, can also be as a roofing, and also to cover the entire envelope. You will learn more in the next slide, which you would see that we have 3 examples that you can see that how ETFE foils has been used as enclosure to cover as a roofing material and also in the last area. So this gives us an example that you would imagine that the foil system is very good and very efficient when you want to cover the large span buildings. Now, what are the benefits of ETFE foil system? So, it is one of the most chemically resistant material. It absorbs the minimum amount of UV radiation. It does not turn brittle or yellowish, and it also provide excellent longevity. And it does not degrade over time. I mean, we have examples of some buildings which were built with ETFE, the enclosures, and even after 33-34 years we did not see any sort of degradation, maybe 5% in the transmission, but not more than that, and they are still standing. So you can imagine that how durable the material is. Now, to give you the understanding that how do we compare this material, we have to look. I mean, the biggest competitor of ETFE foil system is the glass system, because we are talking about transparent enclosures. So, in a comparison, if we do, ETFE cushions can be of a larger size. So, a standard cushion can be as big as 25 by 3 meters, which gives about 75-76 square meter of area. Where we want to make a glass canopy out of it, you have to, the sections are much smaller, 1.52 meters, in that range. So you use more steel, and the glass itself is very heavy, so you use more material to build it, whereas in one cushion the entire canopy can be covered by, if we use the ETFE foil cushion system. In numbers, if we see, uh, if we use a 2-layer system and if we use a 6mm glass system in double pan, then the weight of the glass would be about 15 kilogram per meter square. The ETFE foil system would be 0.8 kilogram per meter square. The profile length would be for glass would be double of what we require for ETFE foil system. And when we do the entire weight calculation with ETFE, we are only using for the material itself, we are only having 66 kilo of material, where for glass it's about 1147 kilogram of material just for glass, the material itself. We are not talking about profiles and everything. So you can imagine how light the ETFE foil system in comparison to a traditional covering system. Now let me give you a bit of insights about the mechanical behavior of ETFE foils. So we do in the lab mono-axial tensile test to determine the strength of the material, that if it's good for construction or not. So we use tensile testing machines. We cut the foil over 1 meter of length at random places. We cut 5 specimens of 20 mm width by 100 mm length, and then we pull these strips. Now if the maximum stress it can bear, if it's more than 33, then they are good for the construction. So here you can see that most of the samples are near to 40 megapascal. So on average they are good for the construction, and this is something that we do every day to assess the basic mechanical strength of the batch of the ETFE foil that we are using to make cushions out of it. There is one more test which is called mono-axial hysteresis tensile test, and now here what we do, that we do, you can say, load a combination of loading and unloading cycle at a higher speed. So each loop would be of 5 seconds and then up to 50 times, and we do it till the cycle reach to a saturation point, and then this give us an insight into how the foil will behave in case of extreme wind loads. And this is something very interesting, and it gives us much more data about how the foils are behaving in the real life scenario. And thank you, hope you enjoyed this short lecture, and we will be coming with more lecture very soon. So thank you.